C3 transforming graphs of functions, example 10. In part A, we are sketching on the same diagram these two graphs. Well, I've already drawn them, so let's just explain how I would have done this if I was doing it by hand. Modulus of x squared minus 2x. I'd first of all think about what would we get if the mod signs were not there. Well, we'd get a normal x squared minus 2x quadratic graph. I know it's going to be a U-shape because of the positive x squared. And then I'd be interested in where does it cross the x-axis. And by factorizing it, I know it will cross the x-axis at 0 and 2. Then the section of the graph which would have been below the x-axis, I'd then reflect it into the positive y section of the graph, ending up with this here. So on this graph, we have this, and then that is the mod graph there. The other graph is simply a straight line graph. Y equals a quarter, take away 2x. It's got a negative gradient and a gradient of minus 2. It'll go through the y-axis at a quarter, and that was enough for me to know how to draw the graph. Now let's go ahead and find the intersections in part B. So part B, we're solving the equation, which is the mod graph equaling the straight line graph. Of course, that's going to be the 2 points where the graphs meet. I just remembered I was going to mark on the graph where the straight line crosses the x-axis, so I'm going to do that now. So on a straight line graph, when y is 0, I get 0 equals a quarter, take 2x. So 2x will equal a quarter, and x will equal 1/8. So here, x is 1/8, and y is 0. And that's where the straight line graph crosses the x-axis. Now back to part B, finding where the two graphs intersect. We can see from the diagram there are two places. Two places where the graphs intersect. Now looking at the graph, in particular this section here, the point where the graph intersects, the x value is definitely between 0 and 1/8. That's why I marked on the x-coordinate of where the straight line went through the x-axis, because I could see the intersection point was somewhere between them. So that x value is definitely somewhere between 0 and 1/8. As for the other intersection point, we don't know anything about that at the moment, other than x is definitely negative there. Let's get on to solving them. So in part B, the fact I'm going to use is that the modulus of an unknown, if it equals, for example, b, then the conclusion I come to is that the value inside the modulus must equal plus or minus b. If that doesn't make sense with a's and b's, try it with numbers, and hopefully it will make more sense. Let's apply that to this situation then. Inside the modulus, I have x squared minus 2x. Now that must equal, positive or negative, the right-hand side. Note the brackets. Note them, they're very important. It's plus or minus the whole of the right-hand side. So we get two possibilities here. Either x squared minus 2x equals a plus 1 times the right-hand side. So I get this. Or x squared minus 2x equals minus 1 times the whole of the right-hand side. Let's solve this one first. Now I can add 2x to both sides. Leaves me with x squared equals a quarter. And then square rooting both sides, I get x is plus or minus a half. Now two solutions there. Looking at the diagram, could we have already found both answers to the question in part B? Well, the one on the left, so looking at the graph, this solution where we know x is definitely negative, could be minus a half. At the moment we can't be sure, but we can be sure about the other one. This solution here. X is between 0 and an eighth, which means a half is definitely not possible. So I'm going to write down here, x equals a half is not applicable. Our graph tells us that x cannot equal a half. That would not be a solution to these two equations. And now I'm going to go back and solve the other possibility, and then see what possibilities that gives us. So let's go back. We have x squared minus 2x, this time minus the right hand side. So that's minus a quarter. So minus 1 times quarter, and minus times minus 2x is plus 2x. Let's solve this. We get a quadratic equation, x squared minus 4x plus a quarter equals 0. Let's put that into the quadratic formula because it doesn't look like it's going to factorize. Now it's good exam technique to first of all quote the formula and then substitute your numbers in. So I have minus b, so minus minus 4 is positive 4, plus or minus the square root of b squared, so that's 16. Take away 4 times 1 times a quarter. 4 times a quarter is 1, so that simplifies to just minus 1 over 2a, which is just 2. So I get 4 plus or minus root 15, all divided by 2. Let's put these numbers into a calculator and see how big they are, because I need to know which is which on our solutions on the graph. So first of all, 4 plus root 15, all divided by 2. On the calculator that says 3.936. And there's a load more decimal places. But that gives me an idea of the size of the number. X is a little bit less than 4. And on my graph, I need the next value between nothing and an eighth. So therefore, this one is also not applicable. Let's go back to the other one, 4 minus root 15 this time. So 4 minus root 15, all divided by 2, 0.0635. According to my calculator. Now that's positive, and it's between 0 and an eighth. An eighth is 0.125, so this one is definitely a possibility. So for my two equations, I've got 4 solutions, but only 2 of them are actually correct. Of the 4 possible solutions, only 1 of them was negative. Therefore, I can conclude that this solution here, x must be minus a half. So that was the only one of the 4 where x was negative. The other 3 were all positive, but only 1 of them was between 0 and an eighth. So let's just conclude here. So the solutions are x is minus a half, and I'm going to give the other one to, well, I'm going to give it exact, in fact. Could give it to 3 significant figures, but it's better to give it exact. So 4 minus root 15 all over 2. And those are the 2 solutions to the equation in part B.